Hello, this is Patrick Fleming, and this is a report on special relativity by Dr. John DePillis. This was presented by the physics department at Georgia Tech. This is Dr. DePillis' book and the description he gives on it. His book is a basic fusion of linear algebra and solves paradoxes like the twin paradox, the train and tunnel paradox, and the pea shooter paradox. It also gives good background historical information on special relativity through history. The basics start with the fusion of linear algebra. So we need to learn matrices and vectors in subspaces to start learning special relativity. Vectors and matrices are good for storing information, like the position of an object, or the velocity of an object, or the direction of an object. These can be stored in vectors, and vectors can be stored in matrices. The basics for special relativity. Basically, if you're shining a flashlight and regardless of you're moving towards or away from someone, the speed of light would still have a constant value. And suppose that someone is running away from you at half the speed of light and you point the flashlight at them, they would have to be moving, their sense of time would be half that of yours. So this goes into the Lorentz transformation, which, to summarize, says that time frames can change for the viewer based on how they see the event, but they do not change in reality. So the formula in the top right shows how the time frames can change for the viewer. The twin paradox is a great illustration of this, which we'll switch over to. So twins are started out on Earth and in a spaceship, and the spaceship is moving at 0.6 times the Earth clock rate. So the child on the spaceship will be aging 0.6 times the child on Earth. And we can watch this illustration. So we can see the ages are 20 years apart, which is a 60% difference. And this basically says that we lose 32 years from this because the clock reading on Earth jumps from 9 to 41 years old for the child in the spaceship. This happens because of general relativity. He sees the Earth's age as 9 years old until he reverses in the next spaceship, which takes him back to Earth, that thrusts him through time and travels 32 years into his future. We can also use this for calculating a boost in the x direction and use physics for space and time. And how we would do that is the matrix below. And these time-like and space-like quantities will combine under the same for the Lorentz transformation. These are the sources I used for the making of this video. Dr. DePillis' book does have the illustrations that I used. They're very interesting, and I would recommend them. Thank you for watching.